Welcome back, friends. Let's look into a math problem on the power. So in this question, it's given the mass of the car. Mass of the car is given to us 2000 kgs. It's traveling up the hill with the constant speed of 90 kilometers per hour or 25 meters per second. And the force of air resistance, so I'm going to assume I'm going to take it as a force of friction, which comes out to be 450 newtons. And the slope of the hill is 6 degrees. So theta angle given to me is 6 degrees. Draw the free body diagram to show the external forces on the car as it moves up the hill. So this is the 6-degree angle which is given to me, and this is the car which is trying to move up the hill with the constant speed of 25 meters per second. And I wanted to draw the free body diagram off for this one, so I'm going to change the color. So the first of all, the force due to gravity is acting in the downward direction, so this is Fg. And if I take the component of this along the x and y direction, so this becomes Fg cos theta. So if you're not sure why this is Fg cos theta, you can watch my videos on the force. And then this will be Fg sine theta, and then this angle will be theta, which is equal to 6 degrees. And then this is the normal force, which is equal to Fg cos theta. And then this value Fg sine theta can also be shown in this direction. This becomes Fg, and then there will be another force because there is a frictional force also acting. I'm going to change the color. So this will be force due to friction, which is equal to, in this case, is 450 newton. And then I wanted to find this is the free body diagram, and determine the force needed to maintain the car speed. So this is what I wanted to find, force applied. Okay, so now if I wanted to find the force applied, I'll go and look into the equation of force on an inclined plane. So F net is equal to F applied plus minus force of friction minus mg sine theta. So all the forces acting along this plane, along this inclined plane, I'm summing up them. So if someone hasn't looked into those force videos, just to make it easy for them, I'm just looking all the forces acting on this inclined plane. So F net is equal to ma, and F applied, which I wanted to find out. And then this force due to friction is acting in the opposite direction, in the left side of the car, this towards the left side of this car. So this is negative, whereas negative force of friction, and minus mg sine theta, which is also acting on the left hand side. So this is moving with the constant velocity. Anything moving with the constant velocity, acceleration becomes 0. So this is 0. This is force applied minus force of friction given to me is 450, and minus mass is given to me 2000 times 9.81 times sine of 6 degrees. So if I calculate this value, so this value, force applied minus 2095.8. Oops, I think I made a mistake. Sorry guys, I'll do it one more time. Sorry. So I accidentally added 45. So 2000. So this is 2500.8, and this goes on the other side, becomes force applied comes out to be 2500.8 newtons. I've calculated the force applied. Now I wanted to find the power output of the car engine to maintain the car speed in the forward direction. So there are two different formulas which we learned in the last lecture. One was power equal to mgv, another was power is also equal to force times velocity. So which formula looks more suitable to me, I think this formula looks more suitable because I have already calculated the force and the car is moving with the constant velocity of 25 meters per second, and I wanted to find the power value. So I'll use this formula, power equal to force. How much is the force? 2500.8 times velocity value comes out to be how much? Velocity value is 25. So I'll multiply this value with 25. That's gonna be, power value comes out to be 62,521. I'm rounding this value, this much joules per, this is this much joules per second, which is also equal to watt. So that is the power output. So hopefully you were able to understand how to solve a math problem on power. So I'll see you with another problem in the next video.